This video is for 13.1. We are going to be starting to take all of the areas that we have been learning about of rectangles and squares, triangles, trapezoids, and we're going to be putting those together to find the surface area. So let's start with our spark. So if you haven't already tried your spark for today, go ahead and do that and then come back and see how I thought about this. So this tells us that Caleb built a rectangular box to store his cast iron oven when camping. He wants to paint the outside of the box, so all of the surfaces of the outside, and so he wants to paint the outside of the box and has enough paint to cover an area of 14 square feet. So he has enough paint for 14 square feet. Does he have enough paint? So he wants to paint the whole outside. This is how much paint he has. Is that enough? So let's look at this front rectangle. This measurement going across, sorry, that was not a straight line and I covered up the numbers. So this measurement here is 2.5. So the base of this is 2.5. And then we are looking here for the height. So now this 1.5 is talking about this line here. So we need to find where on this prism does it show the same straight up and down line. So we can look over here. This line's the same, but it doesn't have a measurement. We can come back here. This line is also the same, and it is 1 foot. So the base is 2.5, and the height is 1. So 2.5 times 1 is 2.5. So the front of this is 2.5. We need to think though, right? This is a rectangular box here. And when I'm thinking of this, it has the same back. The front and the back are identical to each other. So I actually have 2 of these. 2.5 times 2 doubled is 5. So the front and the back together equal 5 units. So now let's go ahead and let's look at our side here. So it has a base of 1.5. So now we're doing the sides. We have this side, and we also have this other side over here that we can't see. So we have 2 of these same sides. So the base is 1.5. And the height, remember this line was the same as this one, is 1. 1.5 times 1 is 1.5. That's for one side, but I need the other one, the left and the right side. So 1.5 doubled is 3. So we have 5 for the front and the back, 3 on the side. So total, we've used 8 of our square feet. So let's see if we have enough paint left over. So we need to do the top and the bottom now. So the top here, right? So this line doesn't have a measurement on it, but it's the same as this one here. So now we're doing top and bottom. So 2 of the same sides. The base is 2.5. And we're looking across here for this other measurement is 1.5. So 1.5. Let me go ahead and do that math here. So 5 times 5 is 25. 10, 11, 12, and my placeholder, 5 and 2 times 1. So we end up with 5, 7, 3, but I have 2 decimal places, so 1, 2. So just the top of the box is 3.75. But remember, I've also got the bottom that's exactly the same. So I'm going to double my top and bottom. So there's 10, 14, 15, and 6, 7 with 2 decimal places. So the top and the bottom together are 750. So do we have enough paint? If I add these up, 750 and 5 and 3, so we can fill these in with zeros here, is 5, and here's 10 plus 5 is 15, and he only has 14, enough for 14, so no, he does not have enough. If he didn't paint the bottom, he would have enough. If he just painted the sides, the top, the front, the back, and not the bottom that it's sitting on, he would have enough. But if he wants to paint all of the outside, then no, he does not have enough paint because the total area, this is still, we're measuring in feet squared, because every time we just found two dimensions, base times height, base times height, base times height, still just two dimensions. So we found 15.5 feet squared is how much surface area he has. So let's look at our goals for today. So we are going to make and use nets. We'll talk about what those are to find the surface area of rectangular and triangular prisms and pyramids. And we'll talk about all of those words today. So your goal, if you can make and use the nets to find any type of rectangular or triangle, pyramid, and prism, year 3, that's where we want you to be today. If you can just do rectangles and prisms or pyramids, then that's a 2. If you can just do the prisms like the ones we just did with that box, if you can just find boxes, then that's a 1. And if you can do it with or without the nets, all of the different shapes, and you can see it on the paper and folded out, then that is a 4. So we'll talk more about what these nets mean. So if you can do it with the net and the measurements, that's a 3. But if you can do it without the net, then that's going to bump you up to that next level to be a 4. So before we get started, we've got a lot of information we need to talk about to make sure we're using the right vocabulary. So a solid figure is a 3D figure because it has 3 dimensions. So these 3D shapes, right? 3D have 3 dimensions. It has the length, it has a width, it has a height. So length goes across, the width goes back, and then the height goes up and down. So a net is an arrangement we can make that takes these closed figures and unfolds them. So here's a 3D shape. So this looks like a cube because it's made up of squares that are all the same. So it's a cube. And so it has this base here. The base is still what it sits on, just like if I have a 2D shape, the base is what it sits on. Here we can see the base is what it sits on. Here's our base. It has a top, and you can see, right, it's got to be connected somewhere else. It has a front, it has a back, and it has 2 sides. So they took this and they unfolded it to show us the different shapes we have here. So we've been focusing on area. We've been finding the square units that cover the 2D shapes using those formulas, base times height. If we're talking about triangles, we cut them in half. So we're going to use those same formulas and we are going to find the surface area. So we're going to see how many square units cover a 3D shape. So we're going to find each of the shapes and then find the sum of them. So we're going to add them together. So find each individual shape, add it together. So the 3 is if you can unfold this shape and then find the area of each one and add them together, that's a 3. If you can do it without unfolding it, that's a 4. So sometimes it can be hard to look at these and visualize the front, the back, the side, what shapes it has. So that's why unfolding it can help us visualize exactly what shapes we have here. So, and I'll show you some other ways that I like to think about them too. So let's talk about the prisms and the pyramids. So prisms have 2 equivalent and parallel bases. So it has a base on the bottom and the top of it is exactly the same. It's the same shape and they're exactly in the same angle. So if one slanted, the other slanted. So they're exactly the same. The type of prism is categorized by the shape of the bases. So you look at what is it sitting on? Does it have another one? Then it's a prism. What is the shape? That's what type of prism. And it always uses rectangles to connect the 2 bases. So if we look at this one here, we can see this rectangle here, and it has this matching one across from it. So it has a top and a bottom base that are exactly the same and parallel. And then it has, so this is a rectangular prism. And then we can see, right, it has this rectangle and this rectangle. And then it also has a different type of rectangle here on the side and over here on the side. So it's all connected by rectangles, a rectangular prism because it sits on a rectangle. So next we have what we looked at before is this sitting on the square. It has another square exactly the same across from it. And then it's connected by all of these squares or rectangles that are exactly the same. So when every figure on it is a square that's exactly the same, this one is a cube, or we could call it a square pyramid or square prism, but a cube is another name for it. So finally, the last prism is we have this one that is a triangular one, because right across from it, we have the exact same triangle and they're parallel. So we have a triangular prism. And the triangles are connected by rectangles. So you can see a rectangle here. There's a rectangle on the back and a rectangle on the bottom. So all of these are connected by rectangles. So here we have a rectangular prism, a cube, and a triangular prism, because the bases, the two shapes that are the same, are rectangles. So these are the prisms. So now let's look at their nets here. So these can be sometimes kind of tricky to understand. So I'm going to actually make me bigger here. Okay, so we've got this rectangle here. You can see, right, I've got it all folded up here. So it has the base, the top, it's got the sides, it's got a front and a back. When I unfold it, it looks like this shape right over here. So here was the base that it sat on. So here's my base. And then, so here's my base, right? Across from it, so the base is sitting on the bottom, right? That top can't just be right next to it. Otherwise, we'll just fold on top of it. So the tops of prisms, sorry, I'm trying to get the, goes on top of it, and they're connected by sides. So here's the base down here. Here's the top, and then it has two sides that connect those. And then out to the side, it's got these other pieces that fold up to it. So here's the base. Here's the top. Here's a side. Here's a side. And then I guess this would be technically, hold on. So here's one that's the front, one that's the back, and then it has these two sides. So here's our base, right? And it folds up. Here's a side. Here's a top. Here's the other side. Here's a front. Here's a back. There we have a rectangular prism because it sits on a rectangle. So it's made up of different rectangles, possibly squares, depending on what size your rectangles are. So we just need to identify, right? It has 4, 5, 6 rectangles that make this up, and they can be, 2 of them will always be the same, right? These will be the same, these will be the same, these will be the same. But they could be 3 different types of rectangles. Okay, let's take a look at our cube here. So our cube, right, it folds up to a perfect square. So everything about it is square. The bottom is square, the top is square, the sides are square, the front and the back are square. And it's going to look very similar to that rectangle when it unfolds. And we've got these pieces here. So here's our base that it's sitting on. It can fold up. We've got the top here. Here's our front and our back. And then our 2 sides fold up as well. So this is a cube. It's made up of 1, 2, 3, 4, 5, 6. Whoops, sorry, wrong way. Everything is backwards on here. So it's made up of 6 squares that are all exactly the same. So once I know one of them, I know all 6 of them. So once I find the area of this one, I just need to find 6 of those. So that makes a cube. Okay, so next we have a triangular prism, Let me find my triangular prism over here. So you can see it's made up of 3 rectangles. So 3 rectangles, those are the sides. And when I fold up those sides, notice what shape do they make? Oh, can't find the camera. It makes a triangle, right? And then here's a base, that's a triangle. Opposite side, base, that's a triangle. So it has 2 triangle bases, and each of the sides are a rectangle. So it wouldn't matter if I put the triangles connected to this top one here, right? Because they would just fold up wherever they are, and the other 3 sides fold together. So, but I couldn't put 2 triangles on the same side, or then I'd be missing this and have another triangle here, and they would overlap each other. So you do have to think about where would they be on the net. So a triangular prism is made up of 3. Why do you think it's 3 sides? Right? Because our triangle has 3 sides, so it needs 3 connecting pieces to get it together. So a triangular prism, 2 triangles, and 3 rectangles. If you notice, right, our rectangular prism has 4 rectangles and the sides that fold up together because this shape here has 4 sides. So it needs 4 things that go around together. So those are our prisms. So let's go and take a look at pyramids now. So pyramids, oh, sorry, this should say pyramids. So pyramids have one base, only one base. So it sits on one thing. The type of pyramid is categorized by the shape of the base. So the square, rectangle, triangle, whatever it is. And then the sides are always triangles that connect together to one vertex or one point. So let's take a look at these here. So we can see our base here is this rectangle. All of the things coming off of the rectangle are triangles, and they fold up to one point. So when they have one point up here at the top, triangles with a shape on the bottom, this is a pyramid. So this is particularly a rectangular pyramid. It needs 4 triangles and a base to connect together. So this one here, we have the square on the bottom. Squares have 4 sides, so it needs 4 triangles that connect to one point. And then here we have this triangle on the bottom. So it's got a triangle on the front, a triangle on the side, a triangle on the side. Triangles have 3 sides, so it needs 3 more triangles that fold up to this vertex. So let's take a look at their nets now. So let's start with our rectangular pyramid here. Can I find my rectangular pyramid? Okay, so it's very similar to a square one. I don't think I have a rectangular one over there, unless it's hiding. It very well could be. So let's talk about these 2 squares and rectangles. So here's the base, right? And then you can see it has the pointy top pyramid. So it's a square pyramid, and all of the shapes that go around it are triangles. How many triangles does it need? Well, it has 4 sides. So if I unfold this, and you can see this one, right, looks different than this here, but it has 4 triangles that fold up together. And then the base just folds there. Okay, so we've got our square and 4 triangles. So yes, this net does look different than this one, but it's made up of the same shapes, a square and 4 triangles. I like to draw mine like this. This one looks a little bit different, but it's still made up of the same shapes. So this one, the rectangle, would be exactly the same, except for the base would just be a rectangle. So let's look at our triangular pyramid here. So on the bottom, we have a triangle. So here's my base. And at the top, it makes that one vertex point. So it's made up of a triangle on the bottom. So to go around 1, 2, 3 triangles, when I unfold, there's my 3 triangles that matches that net there. So we are going to be using these pyramids and these prisms. We want to see how many sides does it have and draw these sides, because sometimes these can be kind of confusing to look at and be like, what shapes are those made up of? So is it a pyramid or a prism? what is the base? What are the sides that go around it? And as you draw each of those out, that can help you identify all of the areas that we add together at the end. Okay, so let's go. So I know that was a lot of information, but we want to know that to help us with all these problems. So we're going to start here on number 1 with a cube. Okay, so we've got our cube. And a cube is a closed 3D figure. So closed means, it folds up and every surface is closed up. So like open would be like that. Okay. So look at the cube. How many faces or sides, so face is a side, does the cube have? So think of like a dice or a box. So think of how many sides does it have? So I can see, it's got the base here on the bottom and it has a matching top. So there's 2 sides. It has a front and a back. So there's 2 more sides. And then it has a side and a side. So it should have 6 sides, right? So here we have our cube, has a bottom and a top, a front and a back, a side and a side. So altogether, it has 6 faces. So prisms that are rectangles and cubes will always have 6 sides because it has the top and the bottom with 4 sides and needs 4 connecting pieces, 4, 5, 6. So let's look at these nets. Which one of these do you think is going to fold up to make a cube? So this one here, this first one, looks like my net here. So let me make me a little bit bigger. So it has this base here we can set it on. Then it has a side. Then it has a top. And it has the other side. Then it has a back and a front. So this one, yes, will make a cube. So let's talk about this one here. So this one is kind of hard. Let me see if I can. So it doesn't have this piece here, and it's got an extra one here. Oh, I'm going to get creative here, guys. It's got this extra one here. I know it's not the same size, but it will help us think about it. Okay. Sorry, the camera's backwards. So if I fold this in here, and so this makes, it made a square, and the one I'm holding back here is gone. Can I fold it up in there? There we go. Okay. So, this made the square here. And then if I fold this over, what's going to happen to this last piece? It folded over on top of another one, and we're left with an empty piece here. So when we drew this one, we need to have this piece over on the other side because then they'll connect. Otherwise, it folds up on itself. Seems right. It folded over on itself. We had a piece 2 times and not the one that we needed. So yes, they both have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, they have 6 faces. And a cube has 6 faces. So yes, they could make a cube. But this one is going to fold up on itself. So it will not actually close up. So how do you find the face of one of these cubes? So if you just had this one square here, how would you find the area of this one flat square? Well, we know, we would do base times height or length times width, or if it's square, side times side, but they all mean the same thing. So if each of the sides of the cubes is 4, this side is 4, the base is 4, and the height is 4, what is the area of this front piece? Well, base is 4, height is 4, so this is 16 centimeters squared just for the front. Now, how do you think we would use that information to find the whole entire thing? Well, we know we have 6 faces, and since they're squares, they're all exactly the same. Every one of them is the same size. So this piece is 16. That means this is 16, this is 16. Every single one of these is 16. So 16 times 6 will tell us that surface area. So we found one of these times it by 6 since they're all the same. And that will tell us the area we need to cover each surface, right? Surface area. So go ahead and complete task 1 and then come back when you are ready to do task 2. Hey, task 2 this time is talking about a pyramid. Let me grab my pyramid. Sorry, I shouldn't have put it on the floor. So we've got this pyramid. And yes, remember their net looks a little different than mine, but we still have 4 triangles and a square. So let's look at our pyramid here. So I can see on the bottom, we have this square. So find the square. So this is 5 and this is 5. So 5 times 5 is 25. So we know our square is 25. So how many faces does the pyramid have? So let's think about how many sides the pyramid has. So let's start here. We've got our base, that's a square. I know a square has 4 sides and it needs a triangle connected to each of these when it's folded up. So, right, here's one triangle and then this triangle connects to this side. This triangle connects to this side and this triangle connects to this side. So this has, since it's a square, 4 sides. So that means it has one base and then it has 4 triangles to go around it. So this actually has 5 total faces. So let's label what we know. Sorry, I got a little carried away here with finding the square here. We will do that, but so this wants us to label the dimensions of the pyramid. So let's just look at the square here. 5 and 5. So the base is 5. The height is 5. So now look at this pyramid. Can you find the height of one of the triangles? So I know there's a lot of lines happening here. So look and see, can you find one that goes from the base to the tippy top? This line here is representing the height of 7. So every height is 7. All of these are 7. All of the bases are 5 because it's a square. So now let's use that information. So how many faces does this shape have? It had 5. So these are the steps I like to use as I work through these problems. So you can draw this net and you can take this shape and say, okay, I folded it out. You don't even have to draw it perfect, okay? You just need to draw the shape. So, right, I know it has this square on the bottom. That's the base. I know since it's a square, they're all the same. So that means this triangle is 5 by 7, 5 by 7, 5 by 7, 5 by 7. I have this triangle and I have 4 of those. So I know that this is 5 and 5, and the formula to find that is base times height. So I wrote down the formula. Now I'm using the formula. Base is 5, height is 5. 5 times 5 is 25. So let's talk about this triangle now. So, right, we know that the base is 5 and the height is 7. How do you find triangles? Base times height divided by 2. The base is 5. The height is 7. And I'm going to cut that in half. Now, once I have that, that's one triangle. How many of these same triangles do I have? I have 4 of them. So once I know 1, I'm going to times that by 4. Then I'm going to take all the pieces and add them together to find the sum. So I'm going to take 25 and I'm going to take this answer and I'm going to add them together. So go ahead and try that and then complete task 2 and come back when you're ready to do task 3. Hey, here we have a rectangular box prism. So Chandra is making a jewelry box. So here's her jewelry box and wants to know how much wood she needs to buy. So she needs to know the surface area of each of these pieces. So you can see her net looks a little bit different. They just took one of these pieces and have it here, but it will still, as long as you have it on one side, will fold up here. So let's label what we know here. So, and that's sometimes this can be confusing to be like, okay, what is what? just go piece by piece. Let's start with the top here. So we can see that this top here is 7. So that means all of these, every time you have this same line, is 7. So all of these lines are 7. You can even color code them like I am. I'm going to say all of these ones that go this way are 7. So now let's look. So that's our length. So now let's look at our width. So here we have 4. So we can see this is shorter, this is longer, shorter, longer. And the other measurement we know is 3. So we're going to label these longer pieces as 4. So anytime I have this longer piece, it's worth 4. This, right, these are going to connect to each other. This right here folds up and touches that. So if this is 4, that touched it, that's 4. They fold up to each other. So this is 4. This will, right, close to this and 4. And our last piece, right, was 3. So here's 3, 3, 3, 3, 3, 3. So any of those shorter pieces are 3s. So you can see, right, if I fold this around, these are going to be the same. This is the same as this. So I know this can look really confusing. We're going to practice pulling them apart for the next few days. So remember, we are just learning this. So take a deep breath. You can do this, okay? So we know all of these dimensions. So let's start and go step by step through my steps. So how many faces does a box have? Well, I know I've got 6, and it's a box. The top and the bottom are the same. So I have 2 tops and bottoms. I have a front and a back, and I have 2 sides, 2, 4, 6. So I really just need to find 3 rectangles and then double it. So I'm going to draw my top and the bottom, and I've got 2 of these. So here's my top and bottom. So let's look at our dimensions here. 7 by 4. So this is 7, this is 4. How do you find? So we drew the shape. We're going to write down the formula, base times height. Then we're going to use the formula. 7 times 4 is 28. But remember, I have 2 of those. So we want to double that. 28 times 2 will tell me the top and the bottom. So now let's look at our front and our back again. So I'm going to draw my shape. How many of these do I have? Front and back. I have 2 of them. So we drew my shape. We're going to write down the formula is base times height. So let's look. The base is, right, this same line is 7. The height of it is 3. So this one is 7 by 3. 7 times 3 is 21. But remember, I have a front and a back of those. So I need to do 21 times 2. So there's 2 sides, 4 sides. Now I need to find this piece here, or it's right over here on this side as well. So this line is 4. So I have my sides, and I have 2 sides. The base is 4, and the height of it is 3. So I think that's the hardest part, is just finding your dimensions. So, right, this line is the same as this one. This line is the same as this one. So 4 times 3, so base times height. 4 times 3 is 12, but remember, we have 2 of those. So we're going to times by 2, times by 2, times by 2, and then add them all together to find the total surface area. So know how many faces it has. Draw them each out. So even if you don't draw it out in this net, showing me and breaking it up is what you're going to want to do. You've got to do this work. You guys, I promise, I don't just do this in my head. I draw out the pieces. If you can see my work, I promise I will show you actually as soon as we're done with this. Okay. What is the formula to find this shape? Use the formula and then add all your pieces together. But don't forget, if there's 2 of them, make sure you find both of those. So go ahead and complete task 3. And then, oh, that is all of it. Okay, so finish your task today and try your check for understanding. We're going to keep working on this for a few days. So take a breath. You are doing great. I want to show you. Let's see. Right? So I promise I don't just like make this up in my head. Okay? I do the same work I'm asking you guys to do. So if I'm finding the surface area of a shape here, you can see, right? This is made up of 2 different triangles and a rectangle. So this is a pyramid. It had a bottom, 2 triangles on 2 sides, 2 on the other side. And I wrote everything down and did my work. I am not asking you to do anything I won't do myself. But when you break it up piece by piece and solve each piece, it's so much easier than just trying to look at it like a 3D shape. So break it up, find the area of each piece, add your pieces together. So finish your Spark and your tasks, your check for understanding, and then we'll work on our homework tomorrow. You've got this.